We'll have a look now at the curve of statical stability, or the GZ curve that you have in your stability book. And here we have a typical example of a GZ curve. At your level, you're not expected to calculate areas under the curve, and you're not expected to calculate values to actually sketch the curve, but you are expected to know the 6 values that you can take off a curve, and you're expected to know the significance of the curve. In this video we'll just simply look at the values that you can pick up off the curve. So on the bottom scale here you'll see 0 through to 90, and that's degrees, and that indicates the angle of heel. So the vessel, when she's heeled over due to an external force, this indicates the angle of heel. So we're talking here about a vessel out at sea. This isn't a vessel loading cargo in port, this is a vessel at sea inclined by an external force. On the left hand side you've got the GZ and the GM that you can calculate. Of course that's in metres, and that's going from 0 up to 3 metres on this particular curve. So let's look at the 6 values. Well, the first value you can get is what's called the range of stability, and the range on this curve is from 0 through to where the curve cuts the baseline. So it starts off at 0, cuts the baseline of around 71 degrees. So in this instance our range of stability is from 0 to 71 degrees. So if you were to write what your range was, you wouldn't just write you have a range of 71, you must write that the range is from 0 to 71. 71 degrees in total, but the range goes from 0 to 71. So that's the first value. The second value is the point or the angle of vanishing stability. In other words, if the vessel reaches that, you're not coming back. And on this particular curve it's 71 degrees. So it's simply where the curve cuts. So when we've talked about those first 2 values, you can see that they're related, that the range is 0 to 71 degrees and the angle of vanishing stability is 71 degrees. So that's 2 values that we've got out of the 6. The next 2 are related as well, and we're talking about the GZ of the vessel, or the righting lever. So the maximum GZ of the vessel, well, when we look at a curve, when we think about this logically, it would probably be at its highest point. So as the vessel is heeling over and gets up to this level here, the size of GZ, as she heels over more and more, then the GZ size will increase, and we discussed the GZ in a previous video. So on this particular curve at 47 degrees, that's the peak of the curve. So we can say that our maximum GZ at 47 degrees, and we go across to the left, is 2.25 metres. So what that's telling us is that when the vessel is heeled over due to an external force and it reaches 47 degrees, our GZ at that point is going to be 2.25 metres. And if we multiply 2.25 metres by the displacement, that will give us the moments that are created, or the torque or the moments to bring the vessel back upright. So that's 2 more of the values. So we've got 6 at the moment. We've done the range of stability and the angle of vanishing stability, and we've just looked at the maximum GZ and the angle at which it occurs. Now with 2 more values. One of them is called the angle of deck edge immersion, or also known as the point of contraflexure. And contraflexure means the point at which the curve, if you look at this curve here, if that curve carries on, it will just carry on going upwards, and then you've got a curve here, and if that curve carried on, it would actually go down there. So at that point the curves actually start going in different directions, so contraflexure, they're going against one another, and that's the angle of deck edge immersion. And on this particular one, we're looking down, it's probably about 35 degrees, something like that. What that means is that when the vessel is inclined or heels over to 35 degrees, the deck edge will be immersed. And that value, generally when students look at that, there can be a range of 5, 6, 7, 8 degrees difference between everybody, because it's just your interpretation of the curve as it changes direction. So that's the fifth value. Now the sixth value is the GM of the vessel, and this is a little more involved, but it's a most important value. And you need to, first of all, to get the GM, you need to mark a point 57.3 degrees on the baseline. 57.3 degrees represents a radian. You don't need to know what a radian is or how you get a radian, you just need to remember 57.3 degrees. Draw a vertical line straight up. Then get your ruler and you draw a tangent to the curve. So if I was calling this our ruler, I'd put my pen on the point there, and then I need to draw that line as a tangent to the curve. In other words, as I start drawing the line, it touches the curve. And I draw this tangent all the way to where it cuts to 57.3 degrees. So I've drawn 57.3 degrees vertically upwards, and I've drawn this tangent, and it's gone along to where it cuts that curve there. And at that point, I draw a line straight across, and that will be our GM of the vessel. So the vessel's GM, metacentric height, in this instance is going to be 0.99. So three things you have to do. First of all, draw a line vertically upwards at 57.3 degrees. Draw a tangent from 0 here, and this particular curve, a tangent to the curve, and where it cuts 57.3, draw a line horizontally straight across, and that will be your initial GM of the vessel. So that's the 6 different values that you can pick off the curve.